This short video will show you how to find the properties of rational functions when you are given the equation. Specifically, we'll be looking at how to find wholes, vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts, domain, and range. Here is an example. Here we have 2x squared plus 4x divided by x squared minus 4. We will first simplify both the numerator and the denominator, which simplifies to, first we will look at the greatest common factor between 2 and 4, which is just 2, and between x squared and x is just x. Now, after pulling out 2x, we will be left with x plus 2. The denominator is a difference of perfect squares. X squared minus 4 is a difference of perfect square. The easy way to factor this is to recognize the general form. X plus 2 and x minus 2 is a pattern for difference of squares. So we will look for common factor between the numerator and the denominator, which happens to be x plus 2, that is common between the numerator and the denominator. We are going to cancel out this common factor, and we'll be left with 2x over x minus 2. Now, whenever we cancel out a common factor, we know that tells us there's a hole in the graph of the function. The hole is located at the x value for which the factor will be 0. So in this case, we're looking for the x value for which x plus 2 will be 0, and after solving for x, we'll end up to have x equals negative 2. So this step leads us to the x coordinate of the hole. So what we have right now is the x coordinate of the hole. To find the y coordinate of the hole, all we need to do is to bring down this expression right here, the simplified version of the original function. We'll bring it down here and write it and plug in x equals negative 2 into the expression. Plugging in x equals negative 2 will leave us with this. 2 times negative 2 is negative 4, and negative 2 minus 2. I wrote it backwards. Minus 2. Negative 2 minus 2 is negative 4. That gives us a division of negative 4 by negative 4, which is 1. So the hole is located at negative 2, 1. Next, we'll look at the vertical asymptotes. We're going to copy down the expression that is left, this expression right here that is left, the simplified version, and look at the expression. We know that a vertical asymptote exists at the x values for which the denominator of the simplified version will be 0. We don't want a 0 at the denominator. That will make the expression undefined. So we need to set this denominator equal to 0 to find out the x value for which the expression will not be defined. Excuse me, I need to erase that and call it x minus 2. X minus 2 equals 0. That leaves us, when we add 2 to both sides, x equals 2. So the vertical asymptote is at the line x equals 2. Now let's look at the horizontal asymptote. We'll have to remember the rules, the 3 basic rules for determining the horizontal asymptote. Rule number 1 says that if the degree of the numerator polynomial is the same as the degree of the denominator polynomial, then the horizontal asymptote will be the ratio of the coefficient of the leading term. In this case, x squared at the numerator is the highest power of x. S squared at the denominator is the highest power of x. So they are the same. So the horizontal asymptote is simply the ratio of a and c. A divided by c. Rule number 2 says that if the degree of the numerator polynomial, in this case the degree here is 3, is greater than the degree of the denominator polynomial, in this case the degree is 2, there is simply no horizontal asymptote, there is none. And the third rule says that if the degree at the numerator of the numerator polynomial is smaller, is less than the degree of the denominator polynomial, 2 is less than 3, then the horizontal asymptote is simply y equals 0. Let's compare this expression with the rules, the 3 rules. You will agree that this expression is similar to the situation in rule number 1, because the degree of the numerator polynomial is 2 and the degree of the denominator polynomial is 2. Therefore, we can conclude that the horizontal asymptote for this expression is simply 2 divided by 1, because 1 is the coefficient of the leading term here. So we just simply go ahead and write the horizontal asymptote is y equals 2 over 1. Y equals 2. These are the final simplified version of the expression y equals 2x over x minus 2. And now to find the x and y intercepts, what we need to do is to set y equals 0 whenever we are looking for x-intercept, because at the x-intercept, the value of y is always 0. So let's go ahead and set y equals 0. In other words, we will set this expression equals 0 and solve for x. 2x over x minus 2 equals 0. This is an equation that we just multiply both sides by x minus 2. 2x over x minus 2 times x minus 2 equals 0 times x minus 2. In this case, the x minus 2 will cancel, and we are left with 2x equals 0. and x equals 0. This is the x-intercept. In other words, the x-intercept occurs at 0, 0. The y-intercept occurs where x equals 0. So for the y-intercepts, we will set x equals 0 in this expression. X equals 0, x equals 0. So let's do that. Y equals 2 times 0, and then 0 minus 2. 2 times 0 is 0, and 0 minus 2 negative 2. Y equals 0. So the coordinate or the y-intercept is really 0, 0. So far we have determined the whole to be at negative 2, 1 right there. The vertical asymptote we determined to be at s equals 2 right here. And the horizontal asymptote we determined to be at y equals 2 right here. These are the three information that we need to determine the domain and range. We need to know where the hole is at, where is the vertical asymptote, where is the horizontal asymptote. So let's go ahead and find the domain, determine the domain. You recall that domain is the set of all x values that is allowed for this function from negative infinity to infinity, or the set of x values that are allowed. We know that x value is not allowed at the whole and also at the vertical asymptote. So to write the domain for this, we will say all x value from negative infinity to infinity, skipping s equals negative 2 and s equals 2. And this is how we write it. X values such that x not equal to negative 2 and or x not equal to 2. Similarly, to find the range, we will look at all the y values from negative infinity to infinity. And as we're coming from negative infinity, everything is allowed up to the point here, y equals 1, where we have a hole and we have to skip. And then we also skip at y equals 2. So the range for this function is really y such that y not equal to 1 or y not equal to 2, which corresponds to the hole at y equals 1 and the horizontal asymptote at y equals 2. So the summary of the properties will be displayed on the next screen. Here is the summary of all the properties of this function y equals to x squared plus 4x divided by x squared minus 4. We found the whole to be at negative 2, 1. We found the vertical asymptote to be at this line x equals 2. We found the horizontal asymptote to be along this line y equals 2. We also found the domain to be all real numbers except negative 2 and 2, where we have the whole and the vertical asymptote. And we found the range to be all real numbers except 1 and 2. That concludes the video. I hope that you are able to get something out of this. If there's any question, you can always send me a message on ngradepro.com. Bye.